In this video, we will explain the notion of conditional probability. Let's suppose that we have a sample space, then we have an experiment, and here we have the outcomes. We have outcome 1, outcome 2, and we have some outcomes. Sometimes we already know some information of what had happened, and therefore, if we want to know the probability of an event using that information that we already have, the probability is going to change. Let's see an example. Let's suppose that we are rolling a die, then the outcomes are 1, 2, 3, 4, 5, and 6. And this is the sample space. Let's suppose that all the events are equally likely. That means that the probability of each outcome is 1/6. But let's suppose that we already know for some reason that we are going to get an odd number. Then we already know that we will get an odd number. Then the question is, what is the probability that that number is a 1? Then in this case it's very evident that since we already know that we will get an odd number, then the possible outcomes are 1, 3, and 5, and then the probability of getting a 1, if we already know that the numbers are even, this probability would be just 1/3. But let's see how to write this correctly. In this case, the event E, let's see, event E is the event of getting a 1. And in this case, let's suppose that F is what we already know. In this case, what we already know is that we have 1, 3, and 5. Then we're going to write this probability so that we don't confuse it with this. We're going to write the probability of getting the event E, and we're going to write this line, and we're going to read it as given that given the event F, given that we have an odd number, what is the probability of having a 1? And then the answer is 1/3. This would be the correct way to write this conditional probability. This is called a conditional probability, and then it's not difficult to see that this formula kind of makes sense. In general, we have that the probability of E given F is the probability of E intersection with F over the probability of F. Somehow, it is like we can work with a new sample space. If we know something about an experiment, it's like we are changing the sample space to be the 1, 3, 5. We can call this like the reduced sample space, and then in this case it makes sense that this event has probability 1/3 because there is only 3 outputs. But then from this experiment we're going to get this formula, which is going to be very useful. The probability of E given F is just the probability of E intersection with F over the probability of F. Right? This is a formula that is going to be very useful. And notice that from here we get that the probability of E intersection with F is just the probability of E given F times the probability of F. Let's do another example. Let's suppose that we are tossing a coin twice, and then our sample space would be a head, 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 tail, tail, head, and tail, tail. Let's suppose that we know that we get a head, right? Then if we know that we get a head, then this event is the event head, 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 tail, and tail, head. Then what is the probability of getting ahead first? Then what is the probability of this event? Getting ahead first would be head, tail, right? Then according to this formula, the probability of getting ahead first, knowing that for sure we get ahead, then is the probability of E given F, and this is the probability of E intersection with F over the probability of F. But the probability of F, assuming that all the outcomes are equally likely, then the probability of each one of these is 1/4, and then the probability of F is 3/4, and the probability of the intersection of E and F is just head, and head, tail, and therefore the probability of the intersection is 2/4, and therefore the probability of having a head first, knowing that we have a head, is equal to 2/4 divided by 3/4. This is just 2/3. Right? Let's call this example A. Let's do another example. Let's suppose that in the same experiment, let's suppose that we know that the first toes is a tail. Then what is the probability of getting head? Then in this case, what we know, let's call the event that we know F. We know that the first toes is a head. Then this event is head, and head, tail. Right? And what the probability of the event that we want to know is the event head. Then in this case, the probability of E given F is just the probability of the intersection over the probability of F, which is 1/4 over 1/2, and this is just 1/2. Let's do this problem on the right. Maybe before doing that, let me remind you that if you have a sample space, let's suppose that we're rolling a die, then the sample space is 1, 2, 3, 4, 5, 6. And then if we have an event E equal to 1, 2, then we denote by E complement just the set of points that are in omega and are not in E. Then the E complement would be 3, 4, 5, and 6. And it is clear that the probability of the complement of an event is just 1 minus the probability of E. Then let's denote by L of X the event that the student finished the test before X hours. Then, for example, what is the probability that the student finish in less than half an hour? Then it will be the probability of L of 0.5, and according to the formula, we have that this probability is 0.5 divided by 2, which is 0.25. There is a 25% chances that the student will finish in less than 30 minutes. But what information is given to us? If we think about the event L of 0.75, this event is the event that the student finish the test in before X hours. Then what is given to us is that he's working after 0.75. then what is given to us is that the event 0.75, not event 0.75 by the complement, is true. We know that it takes not less than 45 minutes, but more than 45 minutes. Then this is what is given. What is the probability of that event that is given? Is 1 minus the probability of L of 0.75, and this is 1 minus 0.75 divided by 2, and this is 0.625. Now, what is the event that we want to compute? Let's call that event F, and that event is that the student takes the whole hour. If it takes the whole hour, it means that it didn't finish before 1 hour, and for that reason, this event, which is this event is just the complement of L1. Because L1 is the event that the student finished before 1 hour. But here is, if it doesn't finish before 1 hour, it means that it took the whole hour. Then for that reason, the probability of F is just 1 minus the probability of L1, and this is 1 minus 1/2, which is 1/2. But then we want to compute the probability of F given the complement of this event. And the formula says that this probability is the probability of F intersection with the complement of 0.75 over the probability of the given set. We already know that this probability is 0.625, and something that we can notice is that the event F is contained in the event 0.75 complement. If a student takes the whole hour, then it definitely takes more than 45 minutes. For that reason, the intersection of F with this set is just F. And then here we have the probability of F over this probability, and this is equal to 0.5. Right, we already compute this probability over 0.625, and this is 0.8. Then the answer for this problem is 80%. Let's do this problem on the right. In this case, the sample space can be modeled using a tree. Notice that we have that the possible outcomes are either she takes chemistry or she takes French, and if she takes chemistry, then the possible outputs are she get an A, or she doesn't get an A, and if she takes French, then either she gets an A or she doesn't get an A. We can actually say that the sample space is chemistry A, chemistry not an A, French an A, and French and not an A, right? This is the sample space. And the information that is provided, it says that she knows that when she takes French, she will get an A with a probability of 1/2. That means that the information that is given is a conditional probability. Then, to understand the information that is given, let us define these events. D, she takes French, then this event is FA and F and A, because if she takes French, then she will either take French with an A or she will take French and not get an A. And the other event is chemistry. and this event is CA or CNA. But the information that is provided is that she knows that if she takes French, she will get an A with a probability of 1/2. Then the information that is given is a conditional probability. Then the probability that she gets an A in French, which is this outcome, given that she took French, is 1/2. And the other information that is provided is that the probability that she gets an A in chemistry, that means chemistry A, given that she took chemistry, this probability is 2/3. Then we have two conditional probabilities, and we want to compute the probability that she gets an A in chemistry. Then we want to compute the probability of this event. Here we're going to use this formula, that the probability of E given F is the probability of E intersection with F over the probability of F. But remember that from here we get that the probability of E intersection with F is just the probability of E given F times the probability of F. And for that reason, this probability is just the probability of this event, CA given chemistry, given this event, times the probability of chemistry. Right, we are using this formula. Notice that if we solve for here, we get that the probability of this event given this is the probability of the intersection. Notice that the intersection of this event with this event is CA. Then from here, we get that this is 2/3. And since she's deciding what class to take using a fair coin, then the probability that she takes chemistry is 1/2. For that reason, the probability that she gets an A in chemistry is just 1/3. Let's do this problem on the right. Here is the situation. We have 8 red balls, R1 up to R8, and 4 white balls. And then we are taking 2 balls without repetition, and we are going to assume that the probability of each ball is the same. And then the question is, what is the probability of getting 2 red balls? Then let's do this using a tree. We see that the first time we pick a ball, we may get a red or a white, and the second one we get a ball, we can get a red or a white, and we can get either a red or a white. What I'm going to write here, they are probabilities. Here where the probability of getting a red, since there are 8 reds and altogether there are 12, then this probability is 8 over 12. And the probability of getting a white would be 4 over 12. Now, if we have a red one, that means that there are only 7 reds and 4 whites. Then the probability of getting a red again would be 7 over 11. And actually, this is a conditional probability. And the reason it's a conditional probability is because we are assuming that we have a red. Then if we have a red, then the probability of getting another red will be 7 over 11. And if we have a red one, then the probability of getting a white would be 4 over 11. But now, if we know that we have a white, then the probability of getting a red would be 8 over 11, and the probability of getting a white again will be 3 over 11. Remember, these are conditional probabilities. Let's define the event red as this event, red and red white, and let's define this event white as the event white red and white white. Essentially, the event red is that we got red in the first time, and this event is that we got white the first time. Then to compute this probability of this event, let's call it E. The probability of E is just the probability of E intersection with red. Remember, notice that the intersection of these two events is just E, and using the formula, probability of E intersection with F is the probability of E given F times the probability of F. We get that this probability is just the probability of E given red times the probability of red. But the probability of E given red is this number here, right? This is the probability of getting a red ball. If we assume that the first one that we took was red, then the answer is going to be 7 over 11 times, and the probability of red is 8 over 12, right? This is 2/3, and then the answer is 14 over 33.